Alright, hey guys, this is Ryan from 1898A, and we get a lot of questions about our 10 bar, and we're about to take it apart. So here's our explanation video. So I'll start with the drive and everything else before we finally get to the 10 bar because it kind of all ties into that. For the drive, basically our strategy was to be heavy, to have torque, and to have locked middle wheels so that we can't get pushed from the side. So we have our 4-motor, 200 RPM drive, bling drive, directly driven on the front and back wheels and just connected through gears for the middle ones. You'll see that we have a lot of structure in the middle to connect the two drive halves, much more than we needed. This is just to serve both as increasing weight and also just serve as structure at the same time, since we're increasing the weight anyways. The reason we wanted to be heavy was to play really solid defense. We don't really have to be that fast, especially if we're efficient with it, especially because your weight has to be like 1/4 to be twice as fast. We just didn't really worry about weight that much. We bought like these C channels, like 8059 in Turning Point, and we just were hoping to play defense like 8059 did in Turning Point by turning to the side. This is not really an offensive move to prevent other people from playing defense on us. This is actually a defensive aspect of the robot because it allowed us to turn sideways in front of the goal zones and block other robots from getting in like that. And if they tried to maneuver around us, we'd only have to drive straight, which was really easy to block them with. And another thing is, not only that, if they get into the goal zone, we can actually just trap them inside the goal zone through the same way, but reversed. So that's the drive. The anti-tips, they're very small, and they don't really have wheels on them. The reason for this is because the robot doesn't naturally tip. Like if it's filled with cubes, it actually stays straight. More of the weight's distributed on this wheel, but it doesn't tip until we like actually jerk forwards. So how this works is when we jerk forwards, it tips a little bit, right? And that gets pushed into the ground so that when we move forward, let's say this is pushed into the ground, when we move forward, it actually extends out as much as we need it to block us from tipping. That we still tip like once in practice, so we ended up putting rubber bands on that, which aren't on right now, but with the rubber bands, yeah, we pretty much never tip. So onto the intakes. We have them on 18 tooth sprockets. 200 RPM right here. This motor's lower just to allow for this to fold up without interfering with the 10 bar. And they're driving 24 tooth sprockets in the front. This allows for more tolerance when intaking cubes. So basically, even if the cube was here, it would still pull it in because of the large sprockets. If it was smaller, this tread would be like here, and it would end up pushing the cube away like that. Same thing with our large flaps. What the large flaps does is it increases this further, so we have even more tolerance. For the tray, you'll notice that the back is open so that we can back dump into the high and middle towers, and it's a 10 cube tray. We have zip ties and stuff. It's all pretty smooth. Show you guys. It just falls down like that. For the tilter, so the tilter is slightly different from what most teams use. Instead of connecting the driving bar directly to the gear, we actually have it only connected through the high strength shaft. And we tried to reduce slop with the lock bars, if you can see them on the sides, and in the 80 tooth gears that are driving it. The reason we did this and went through the hassle was to get the driving bar as flat as possible in the resting state. And what that allowed for is for this coupler bar to be almost perpendicular with this tray, which gave us more efficient geometry. So the other thing about the tray is it's a cut tray. I'm sure you guys have seen it before. Basically, it just doesn't hit the intakes when it goes forward. And when we want to release the stack, we just spin the intakes outwards, and it works. We just have to tune a little bit to get the right speeds for spinning them out while driving backwards. And the tray itself is a triangle fold, basically folds in like a triangle like many other teams. And that was just really consistent because With the triangle, it only folds like this much. So if we need to flip out more, we just add more rubber bands and it'd still be really consistent. Unlike trays that kind of folded like this, like all the way down, because then the rubber bands have very, very little force pulling out. Alright, so on to the 10 bar. So the premise of the rest of the robot, besides the 10 bar, was just to be super, super consistent, right? We have 10 cube tray, right? Completely meta. And without the 10 bar, this is like a super, super normal robot, right? Besides like the back dump for towers. But the back dump is super consistent, not like a Goofy with an arm. Didn't need any tuning, we just literally pushed them out of the back. And then the front intakes, they were on hinges with rubber bands. So if we need more compression, we just added more rubber bands. This thing, if we needed more flip out force, just more rubber bands as well. And without the 10 bar, flip out worked like every time. We could stack really consistently with the geometry of the tilter. And the drive was really good at playing defense. So it was already like, our idea was to have a solid tray bot and then add the 10 bar on that. So then, back to the 10 bar. First question a lot of people ask us is why the 10 bar? And the reason for that is because we wanted passive intakes, right? We didn't want rollers. We didn't want to lift the rollers because they're heavy. So we had these passive intakes so that we're only lifting structure. And basically the reason we have the 10 bar is because for the passive intakes to release, this cube has to be inside a tower and then you back off, right? And it releases. However, if you had like a 2 bar, it would just lift like here, right? It wouldn't go forward, which is what we needed it to do. So with the 10 bar, 10 bars have a ton of swing. If you can imagine like a sideways scissor lift almost with like 1 extra bar, that's pretty much what we have here. So it extends sideways, right? And it pushes this forward so that it can get dunked into a tower and we can just drive back and release. So then, basically without the rollers, the 10 bar had much less mass to lift, right? Which puts less strain on this motor. And we were originally running it on a 200 RPM 1 to 5, which was super, super fast. But then we switched it to a 100 RPM for consistency. However, if Worlds didn't get canceled, of course, probably could have switched it back and tuned it to be able to do so. So that's the first thing. It's much faster than a traditional 2 bar, especially with the added length of all these bars. Like from here to here is much faster than a 2 bar going through the same angle of movement. So then the other advantage of having a 10 bar that we designed it for was that once the lift is up, the intake stayed down. And not only does that keep all the cubes inside the tray, inside the robot, kind of like a cube ratchet Goofy, where you can lift the arms up to score towers without all your cubes falling out. This is a similar thing, except the added benefit is that the rollers also stay down. Right, and what this allows for is intaking while lifting, and literally at the same time. So if this lift is up, we hold it up, and we have like a tower, that's our target, right, for scoring the cube in. We can pick up any cubes on the ground in that path there, which basically allows for flexibility, more cubes over the course of a match and a skills run. And the biggest thing is in a match we can hoard while playing towers. Like usually you go with one of those strategies. You either play towers after you get your stacks down or you hoard. But with this you can do both and do it at the exact same time. And the other thing with that is it also eliminates pretty much any lift time, because you just lift while driving. There's nothing bad about lifting the cube up, right? Because your intakes will still stay on the ground. So that was the theory behind that. And the last thing was that we just dunked this into a tower and drive back. So it was nested completely inside the tower, hard to score almost every time. So it was pretty hard to actually accomplish that, because there were also some constraints that we had to work around. First one, the robot has to fold within 18 inches, right? So this has to fold to the side. We designed a joint here, and it has to fold on another hinge down like that, and then it's held in place by a pin. Right, it's right here, and basically that attaches back there, and when the tray goes forward, it pulls out the pin and it goes forward. The other thing we had to work with is the tray couldn't hit the claw when this goes forward, right? So what we had to do was only brace it on one side, which made it more wobbly and harder to build because we had to end up putting much more bracing. And also this thing moves to the side when it goes up. So yeah, thanks for watching, guys. Good luck and change it.